Hi everybody, my name is Puneet and that's Prashant. In case you haven't guessed already, we're brothers and co-founders. So if any of you know what it's like to work with your family, how good or bad it is, well, we're a live example of that. So we're here to talk about Diffy, and before we talk about Diffy, I want to ask a question, and it's a yes or no question. You can raise your hand if the answer is yes. So back in 2016, November, Twitter sign-up was broken for 2 days, so new users were not able to sign up onto Twitter. And our stock, at the time I used to work at Twitter, our stock went down by 5%. So how many people remember that? So those of you who raised your hands, you can put your hands down because that never happened. And it never happened because Diffy caught the bug that would have caused for that bug to break Twitter in production. So sorry about that. So the problem that you're faced with as a backend engineer, developer, QA, the problem that you're faced with is that you've just refactored a critical part of your service, and you want to know that when this change gets merged into master and eventually deployed into production, that production won't blow up, right? And this is a very good fear to have. It demonstrates maturity and responsibility. And as a developer, as a QA, you do a lot to make sure that you don't break production, but you're always in constant fear that, as you're making big changes, if things will break or not. And often this fear prevents us from making big changes. If you're a site reliability engineer, an SRE, a DevOps-focused person, then you have an even bigger problem. And the problem is that you don't know what the changes are in the code that are getting deployed into production, right? Because the developers wrote the code, the service owners wrote the code, and now you're sort of hand-holding this deploy into production. So you try to use techniques like canary deploys. So you'll just start up a small cluster, you'll send 1% traffic over to it, and you'll watch for anything out of the ordinary. You'll look at key business metrics, key service metrics on your dashboards. You'll look for exceptions. But if nothing out of the ordinary happens, you'll probably roll it out 100%, and then the new code will be in production. The limitation of this approach is that if the code is broken in a subtle way where the business logic is wrong, you might not see any exceptions, but there is bad code in production that's doing the wrong thing. So at Twitter, we had this tipping point where we were in the process of migrating away from our monolithic implementation on Ruby on Rails to a Scala-based microservices architecture. And this was a great opportunity to break things, right? Because all of Twitter, with like hundreds of millions of users who are like sending massive amounts of tweets at the backend, would see a fail whale if our backends were to go down. So we couldn't take on a lot of risk. And what this meant for the people responsible for the migration over from the monolith Ruby on Rails to the Scala microservices was that it would take 2 days to write the code, but then testing it would take more than 2 weeks, which was extremely frustrating for developers. And I was personally suffering from this problem myself. And this led to the creation of Diffy, where we wanted to prove that, look, this new implementation that you have, either as a result of you wanting to break your legacy monolith and building a new microservices architecture, or you just want to move over from your existing data center, private data center, to the cloud, right? For any kind of big infrastructure migration, you have this problem of having to prove that the old version and the new version behave exactly the same, or within a reasonable margin of each other that is tolerable, right? So I'll let Prashant now take over and talk about the sort of theoretical motivation for different kinds of testing and how Diffy fits into all the different kinds of testing efforts that you might already be taking on.
So at the end of the day, what we're really trying to do here is gain confidence over code changes that we're pushing out to production, right? And there are some standard layered approaches to how we approach this kind of problem. The lowest layer, layer 0, is developers end up writing a lot of unit tests. So let's say you were testing a function or a class where you had some conditional logic within that class. And that led to 5 independent different code paths. To get 100% code coverage, you would have to write at the very least 5 of these test cases. A single test case will get you 20% coverage. Now, most developers are good at this layer, or at the very least decent at this layer. They end up writing a lot of these unit tests. But sometimes these unit tests, the cost of writing these unit tests is so high that you end up spending more time writing these tests than actually writing the code that you're testing. So sometimes developers potentially skip some of these states and the coverage goes down a little. But even if you were to get 100% coverage here, there's a second problem. How do you know this code that you've written works well with the rest of the pipeline, with the rest of your service? This is where the second layer of service tests comes into play, also known as component tests or whatever you may call them. In this particular case, we can assume that the function that you've written is also calling a bunch of different other functions. So let's say we have 6 of these nested functions that are calling each other to make a service. Now, each of the functions are calling 5 paths. That makes it 15,000 tests that you'll have to write for 100% coverage. Now, hopefully by now you've realized that at this layer, the problem has already exploded for us, that writing 15,000 unit tests, 15,000 tests for 100% coverage is just way too big of an ask. A single test in this particular scenario is only covering 0.6% of your, or getting 0.6% of the coverage. Now, there's another problem after this is a single service. What happens when you have multiple such services? So let's say on a request path, you have 4 such services talking to each other. The problem just exploded. It went from 15,000, which was already something you cannot achieve, to 60 quadrillion tests. Now, I don't know about you guys, but this is a pretty high number, which is really, even if you have an army behind of writing QA tests, this is just impossible to achieve for the single solution that you're trying to build. A single test in this particular universe is not going to give you any coverage, so you end up writing tests at this layer for the happy test cases, for the happy use cases, whether they be good or some minor edge cases here and there, but there is no way you're going to get 100% coverage for your entire application. So hopefully this was already, you were already aware of this problem. If not, maybe I've convinced you by now that each layer, the cost of coverage grows exponentially, and it's really, really hard to achieve. But if you really think about why that is the case, it's because of 2 primary reasons. One, when writing tests, you have to think about the combination of the different options that you have for the input parameters, what you're testing the system with. And the second part is, how does it behave against that input? What are the assertions you will have to make sure the solution you've built is working as expected? Diffy solves, or at least tries to solve both of them by providing free test inputs to you and also the free assertion part. So let's talk about them individually. The free test input part, we already know there are RSF users in your production environment that are exercising the code paths you're building out. So why not use that production traffic to run through your system and treat that as your input? Now you can choose to have a sample of this production traffic flow through your system, or you can choose to have your request and response logs recorded and replay them against Diffy. So the sourcing itself is up to you, but the idea here is you are already getting free test inputs, which are your production users. But you don't have to run that system in your production environment. You can run it against a staging environment. So the second part comes in for assertions. Now, assertions are basically you're matching the behavior of your new code, the code that's not deployed yet, against the known good code, which is what we're treating production. So hopefully you're shipping code that's known good to you. And that's what we're considering production known good code. And we're comparing that to the candidate, which is potentially what you ship your new code with. So a thing to note in here is that you still have to provide the environment that you want to test this against, and you can do this with a mocked environment or stage or production. We recommend you do this under stage because mocked has the same problem I was defining right here. In a mocked environment, you still have to think about the inputs. You have to still provide the inputs and the behavior there. So we recommend you not go down the mock path, and stage environment is what we sort of want to promote. So even after assertions, we still have one other minor problem that we have to address, which is what about noise? now that you have these two different instances, the production known good code and the candidate code, there are some variations between these two codes based on non-deterministic behavior of the application. So for example, if your application was returning in a response packet, the time at which the response was generated, some server-generated timestamps. And if the server blocks don't agree with each other, these timestamps will always be noisy, will always disagree with each other. How do you solve for that? Or any random number generation that you're doing, or any non-deterministic behavior that the application may have. It's not a fault of the business logic that you're trying to ship, it's just noise. So let's take a look at the Diffy topology of the architecture to try and see how Diffy handles those cases.
So this is a very basic idea of how to cancel out noise, right? So what is noise? If we think about it, you have known good code. And if there exists noise either in your environment or some circumspect aspect of your code that causes for it to be susceptible, then it will show up whenever you compare the known good code to itself. And that's the key idea behind noise cancellation in Diffy, right? So what we're doing here is that we're sampling production traffic from our production environment. So we've instrumented our production cluster, our load balancer, such that any layer 7 traffic that gets received by the service in production, some percentage of that layer 7 traffic will get copied over and mirrored to our staging environment, right? So as this traffic has been mirrored and sent to our staging environment, Diffy and any of the infrastructure behind Diffy is not on the critical path, right? So the production path is completely agnostic of any analysis that Diffy is doing. So Diffy is standing up as a server and listening on a port and receiving traffic from your production environments. And as it receives these requests, it's multicasting all of these requests to 3 different instances of your code, right? So the first instance at the top here, that's the candidate, right? This is the new code that needs to be tested. The second one here, we call that primary. This is an instance of the known good code that is in production right now. And the third one here, the third blue box here, that's secondary. So that's the second instance of the same known good code that is currently in production, right? So then when Diffy gets 3 responses back from 3 instances of your service, it compares the first 2 responses, which is the old code and the new code, to identify a raw set of differences, right? So these differences include all the different sources of noise that you heard from Prashant about a minute earlier. So now you've got all these differences with lots of noise, and you don't know which ones are real and which ones are not, right? What's noise and what's real signal. So you also compare the responses that you got back from secondary to primary. So you're comparing the old code to itself. And if there are parts of your response that the old code is unable to agree with itself on, then by definition, all of those parts are noise, right? So now what you do is you do an aggregation over thousands of requests to find patterns, and then you're able to identify noise, and then you subtract the noisy fields from the raw differences that you saw between the old code and the new code. And once you do the subtraction, you've effectively done noise cancellation, and you're left with a set of filtered differences that are directly actionable to you as a developer, right? So at this point, we're going to switch over and show you guys what the UI looks like. And we apologize that we were planning on doing a live demo for this, but because of technology constraints, our laptop, the demo laptop didn't agree with the projector here. So we're going to show you a recording instead. What's happening in this demo here is, let me blow this up a little bit. So what you can see is that we have this service that's been stood up, and it's been receiving traffic, and it has a very not a very rich response, but a response reasonable for a demo. So it's the response has these different fields. It has a date field, it has a name field, and it has a timestamp, right? So if there is a regression in timestamps, so timestamps are the typical example of the noise that we talked about earlier, right? 2 servers will never agree on what time it is right now, and it's not your code's fault, right? But it does show up as a difference. So as we move forward in this demo, you can see that there is another kind of regression, which is this name, right? So here what you can see is that your expected value from the old code, from the known good code, was this word Twitter with the first letter T capitalized, but the actual response was all lowercase. There's another example that Diffy is giving you, which is that in another request I saw that the expected response was GTAC, all capitalized, but then the actual response was all lowercase, right? Now this is probably a bug in your business logic, right? This is not some random noise that is happening, right? So you want to make sure that Diffy is able to isolate these two from each other. So this is another field, which is timestamp, which is similar to the date field. So now, as we move forward here, we just turned on noise cancellation. So in the Diffy UI, you have this button here that allows you to enable noise cancellation, which is the technique that we discussed a minute ago. And you can see that all of these other fields, they got grayed out, right? And the only remaining field is name. So Diffy was able to identify that it doesn't know anything about the schema of your service, but by looking at these patterns, it's able to automatically figure out which fields are noisy and need to be ignored versus which fields are not noisy and need to be highlighted in case there is a regression, right? So it highlights this field, the name field, as a field where a regression has happened, right? So now what you can do is you can click on the little icon at the corner of any one of these examples to sort of look at the full-blown request and the response, right? So if we click there, then we see this full-blown example. So what this says is that here's a concrete example of the regression that Diffy caught, which is this was the request. This was a GET request with this particular path parameter and arguments, query parameters. And then these are the responses that we received back. So this is the expected response from the old code with the Twitter with a capitalized T, and this is the response from the candidate code with Twitter and all lowercase, right? So what this does is it makes it extremely actionable for the developer, because the developer is super familiar with their response object tree and their schema, right? So if you highlight a particular part of their schema to the developer and you tell them that, hey, there's a regression showing up here in this particular part, then they can go back to their code and they can use this to fix it, right? From a reproducibility point of view, they can even use this particular request to replay once they think they fixed the bug and see if the behavior has now fixed itself. So at this point, we'll switch back to the presentation. And here we go. So when you show this tool to teams, any kind of leadership in your organization, right? The first thing they want to do with this is automate it, right? Engineering managers were the first ones to come to us and ask for automation around this. Product managers wanted to be on top of all the regressions that were getting shipped into production, because if something is not a regression, it might be a deliberate feature, then they have to explicitly sign off on it. And then tech leads also, who are accountable for the quality of the code, and release managers and QAs, everybody wanted to automate this. So we ended up building a feature into Diffy that exposes an HTTP API that allows any kind of CI/CD system to call into Diffy and retrieve reports, and also send these reports automatically to the teams. So when you deploy your Diffy instance, you can set it up with your team email, and then what happens is that as part of your CI/CD process, anytime there is a regression, your team will get an email. And typically the way this works out is that if you've got, let's say, bi-weekly deploys, or twice a week deploy, then before the next deploy, every morning you've got an email waiting for you when you come into work that says, hey, if master was deployed into production last night, here's how the world would have been different. And that's extremely powerful for engineering managers, tech leads, and QAs, because it gives them the ability to see the future, right? They're able to see what the next deploy is going to look like before the deploy has actually happened. And by being able to see that deploy before it happens, they are now able to preemptively take action and fix any kinds of bugs that would have otherwise only been caught in production, right? So the story so far with Diffy is that I wrote the initial version for my personal use just so that I could ship code faster into production, and it helped me provide enough proof to my team that, hey, my change doesn't break anything, so you should let me merge and ship into production. When other engineers saw that I was shipping faster, they also wanted to use it. So I ended up spending some amount of time making it agnostic to the service schema. Initially, it was just written for my service, the user service at Twitter. And then we ended up making it generic so that it would work for any thrift service at Twitter. So thrift is the binary protocol that we use at Twitter. And so the first version was my personal one. The second one was generic thrift. Then HTTP service owners wanted to use it, so we ended up re-architecting the code base so that it would be protocol agnostic. So now it's extremely easy to add new protocols to Diffy, and currently it supports HTTP with JSON, XML, HTML, all unwrapped. Other HTTP services at Twitter started using it. Then we realized that this is something that is sort of generically valuable even outside the scope of Twitter. So we open sourced the project, and since then, a large number of companies, all the way from Airbnb in the US to Baidu in China, have all started using Diffy. And when we saw the community, gain so much traction, the tool gained so much traction in the community, and people reaching out to us for support and feature requests, we realized that this was going to be a full-time job, so both of us then decided to give up our lucrative jobs in the US and come back to India, and we've now started a company around Diffy. And we're currently working with some early customers for an advanced version of Diffy that we hope to push out into the open source soon for the benefit of the larger community as well. So check out our website, diffy.ai, and at this point, we're happy to take any questions that folks might have for us. Thank you so much.
Pronunciation. Do you understand me? Do you understand me? Yes?
We can understand you.
Maybe it's popular question, but do you have any successful and easy cases of use of Diffy in verbs, put, post, patch, and other cases successful?
That's a great question. So the question is, for any kind of traffic that has side effects like post, put, delete, right? All of this has side effects, right? Get traffic is easy. You can replay read traffic anytime, but if you have any kind of write traffic that changes state, how do you safely replay that traffic? And Diffy doesn't solve that problem currently, right? The way that problem gets solved is by our customers. And so the way that we've seen our customers solve that problem is one, either they invest in a staging profile where they themselves guarantee that it's safe to replay write traffic and guarantee idempotence, right? Or they simply disable write traffic. So by default, if you use Diffy out of the box, none of these verbs, these HTTP verbs, will work for you. You have to explicitly turn on using a flag in Diffy to allow for HTTP side effects to be replayed. The vanilla Diffy implementation, the default setting in Diffy is to not support those verbs. But if the customer knows what they're doing and they have the staging environment where they can guarantee that this traffic can be replayed safely, then they can turn the flag on. So the option exists, but the problem is something that largely has to be solved by the customer and requires a little bit of investment from their side.
Developers in Twitter have successful cases of using, yes?
That's right. So I was myself using this for the user creation path, which creates a new user at Twitter. So I ended up making sure that my staging profile was set up such that it didn't propagate any downstream writes. So basically, in my staging profile, what I did was that when I would try to do a write to a data store downstream, it would just be a stubbed client that would return a 200 OK, basically say that OK, but it doesn't actually do a write downstream, right? So I end up replaying, end up dynamically mocking the behavior of the downstream data store without actually writing to the downstream data store, right? So yeah, it is used successfully.
Hello, thank you for great. I have a question. As I understand, your Diffy is basically focused on web-based projects. So, do you have any examples or customers who are currently already using Diffy for not web-based projects and programs like hosting platforms or something else?
You mean hosting Diffy? Or?
No. Diffy is focused on for web-based projects like Twitter or websites and anything else. Did Diffy used for backend code testing or something else? The idea is great, but it's not clear. Is there already customers who are using Diffy for testing our types of programs?
Other than backends?
Yes. For example.
So there's some interesting, these are fringe use cases. So the majority of our customers are using Diffy to test backend services. So they have HTTP APIs. 90% of the people are just using HTTP APIs, and they're using it to test regressions in HTTP APIs. There are some corner cases that we're seeing which were completely unanticipated. And there were, because really, if you're sort of like a functional programming geek, right, like you're comparing functions here, you're trying to prove equivalence between functions, right? And one way to look at a service is that it's a function, right? It's a function that takes a request and returns a response. So some people have started using Diffy to instrument their code to test functions. We find that use case interesting, and people are free to do what they want. But largely, the value that a tool like Diffy creates is when you're testing something larger than a single function, right? So this particular example that I'm talking about is there's a company out there called Split.io, which does a lot of work in the A/B testing space. And so they use Diffy to do a lot of internal testing as well. And they've open sourced a Diffy replay module that does aspect-oriented programming. So there are Java annotations that you can drop into your code to intercept traffic around a method, and then replay that traffic onto new versions of that method. So you can use it for finer grain testing for Java methods using the hooks that these people have open sourced. And that's, I mean, if people want to use that, I'll go for it. But it's at that point, like, it's so small that you might as well write tests for it because it's just a single method. But yeah, that's one of the more interesting cases that we saw people using Diffy for that we didn't design it for and we didn't expect. So yeah, thank you. Any other questions?
Thanks for the talk.
Sorry, who am I looking at? Oh, all the way at the back, yes.
Yeah, one more.
So there's someone behind you.
Excuse me.
Should I pass?
How extendable Diffy's AI is? Can I extend Diffy's AI to add some weird classifiers, for example?
You want to extend Diffy's AI to do what exactly?
To predict outages of my weird usage of my microservice architecture, for example.
Oh, yeah, absolutely. So there is an extension module, and I'm happy to talk about this. There's an extension module that we're planning on open sourcing soon that analyzes metrics coming out of boxes, right? Because as you've observed, right, like one of the things that's happening as you're sending the same traffic to two different versions of your code is that you have a coherent source of load, right? And when you have a coherent source of load, you can compare the metrics for those two different versions of the code, and you can use those metrics to predict something that is going to happen in production, right? So absolutely. And that has happened. So there was a developer who accidentally, they were supposed to read a value from downstream and reuse it twice in their code. What they did was they refactored their code so that they ended up reading that value twice from downstream, right? So because the data wasn't changing very often, what happened was that functionally the code was correct. So when they tested it, everything looked fine, right? But the side effect was that now there was twice as much downstream traffic, right? And this code was going to be deployed on a 10,000 machine cluster. And the data store was a shared multi-tenant data store. So if this shared data store suddenly sees twice as much traffic from 10,000 machines in production, it goes down. And because it's shared, everything upstream from it also goes down. So the entire company would have gone down, right? So Diffy was able to prevent this from happening because it said, hey, you know what? I'm looking at the metrics, and of the 10,000 metrics I'm looking at, I can see that this one metric is suddenly double the other metric, like compared to the baseline. And so it highlighted this back in a report to the developer, and the developer said, oh, this is nice. Like I am able to now prevent this bug from hitting production, and I can keep my job. So, yeah, I mean, that's definitely a use case that's there.
I'm trying to understand your point about the level of insurance that we have to have before passing this traffic to Diffy. Which level of automation testing is enough to start it? Do we have any automation tests before trying to this new version?
So the way it currently gets used in Twitter, Airbnb, and the few other places that we've been talking to customers with is that it's used as the last thing before a canary deploy, right? So your unit tests have already passed. That's how your code gets merged into master. And then your integration tests have passed. And then finally Diffy does its analysis and then promotes the artifact, or a human has to manually override and promote the artifact before it gets canaried and deployed out to production. What we're seeing is a bit of an interesting trend where people are using Diffy upstream in the earlier stages of the pipeline. So if there is a sort of release engineering process where there are QAs involved, right? What we're seeing the QAs doing is they're using Diffy to do a lot of the regression testing. So where they would otherwise do manual testing by sending requests through some sort of script and then looking at the responses and then doing some sort of a custom comparison for each service, they're now using Diffy to do this automatically. The other thing we're seeing is developers are asking each other for Diffy links in code reviews. So people are saying that even before this code gets merged into master, can you do a comparison between your private branch and master to show me what this refactor will impact, right? Like what would be the result of this? So we're seeing adoption in all the different parts of the pipeline, people using Diffy in all these different places. But the most sort of interesting one right now in terms of the largest volume is the last step before you deploy, right? So the pre-canary step is where Diffy comes in most places right now, where you'd use Diffy to make sure everything's okay. Yeah, please.
Thank you. May I have one more question? Then continue.
Sure.
So you don't have this point to stop writing automated tests at all. Yeah, because it was quite demotivating statements in the beginning when you have a lot of passes to cover with tests. So you don't say so, right?
No, we say that write as many tests as you can, but be cognizant of the fact that you're only covering a very small tip of the iceberg, right? So do as much as you can and leave the rest to the machine, right? Covering thousands of code paths is a machine's job. It's not a human's job. So do what you can and then let the machine take over.
Yeah, sorry. So the point was still like the happy cases, you still have to think about those because that's where most of your production traffic is flowing through as well. So writing tests is good. It's just that getting to 100% coverage is going to be exponentially hard for you. And this is where Diffy can come in and actually help you out with those cases.
And while I'm giving up my micro, you could answer, how long time will take this phase that will give enough information about artifacts from Diffy?
That depends on the service and how much traffic you're sourcing from production. So to get good coverage, for a small service, we recommend 1,000 requests is typically enough. So however much time it takes to get 1,000 requests. So for some large clusters, it can happen within seconds. For some other low traffic instances, we've seen people run Diffy for an hour before they have enough traffic to validate that. And then for some use cases where there are the traffic is even lower, what people do is they record traffic for an entire day or a week, and then they replay an entire day or week's worth of traffic within a few seconds, right? Because the service isn't load bound. So they can replay traffic a lot faster, right? So it's basically it depends on how much request volume you can push through as quickly as possible. Yeah. Thank you for the questions. Appreciate it.
Thank you. I have one little question. You have AI in your domain name. So is Diffy really use some AI algorithms or something for detecting anomalies?
That's a very good catch. So it's very sort of crude AI, if you will. It basically reduces the feature space to 2 dimensions and then does simple equivalent of simple logistic regression. So it's basically setting very basic thresholds on 2 dimensions, right? So you can kind of call it logistic regression, but it's So the point here is that there's plenty of opportunity to make huge leaps and bounds of improvements here by applying deep learning and increasing the dimensionality of the feature set, and that's exactly what we're focusing on right now, where we want to make Diffy even more powerful and the quality of predictions that it does. So yeah, you're absolutely right. There is a lot of work to be done on the AI side. It's very basic and nascent right now.